Okay, for time-wise, I'm just going to do the decagon here on this one problem. But again, what's the key? I'm going to draw my regular polygons, central angle triangle. Okay, remember this is a decagon, so we know the number of sides is 10. So I have my radius, I have my radius. Now this time they gave us the apothem, so I don't have to solve for that one. A equals 10 centimeters. But I still have to figure out the side length when we're working with that. So that's where we get the complicated perimeter stuff. But then I also remember I have to do my central angles. So remember, first, what do you find? And on the other page, I kept doing it in red, the central angle. So I go 360 divided by 10, that's 36. But again, what does the apothem do to it? It bisects it, so that's 18 degrees. Now I just need to solve for the perimeter because I already know the apothem. So when I do that, I really am just going to use the fact that I know the apothem will divide the sides. So I'm going to solve for x. And the cool thing is I get to use tangent. So I'm going to find the perimeter right now, okay? So I'm going to use tangent because that's opposite over adjacent. So I go the tangent of 18 degrees equals opposite over adjacent, so x over 10. I multiply both sides by 10. And I get the tangent of 18 degrees equals x. So if I'm looking for the perimeter, what am I going to do? I'm going to sit there and double it, right, to get the side. So I got 2 times the 10 times the tangent of 18 degrees. And I have 10 sides, so I'm going to go times 10. So what is that really going to be? Well, the perimeter then is going to end up being 200 times the tangent of 18 degrees. But the cool thing is I have everything I need now. I have my apothem and my perimeter. So when I do that, I go area equals 1/2 apothem times perimeter. So I get my 1/2, and if you want, go ahead and put it as 0.5 this time if you want. My apothem is 10, and my perimeter is this 200 times the tangent of 18 degrees. Now it's strictly punching it into your calculator to get this to work, okay? So we go 0.5 times 10 times 200 times the tangent of 18 degrees. And so what do we get here? We get 324.9 square centimeters. And that would be our final answer. And you just punch it into your calculator. It's not like crazy with all the other stuff we've been doing. All right, now let's go down to below. And we're going to actually start talking about, and we're going to get a formula from this, and we're going to derive the formula to solve for the area of this triangle. Because remember, the area of a triangle, and I'm just going to write it here, is 1/2 base times height. So if I was looking at this triangle, which side would you choose to be base? Yeah, I'm going to let this one be the base. But if that's the case, that means I have to go to the vertex opposite it and draw a segment straight down to make the height. So that would be my height. And I would have to solve for it. So then, do you guys see the triangle right here? Even I ignore the base, that I can solve for the height. Which one of my ratios am I going to use? Sine, cosine, or tangent? Well, that's the hypotenuse and that's the opposite, so it ends up being sine. So I go over here and I go, okay, the sine of 71 degrees, and again, we're ignoring that bottom part there, equals opposite the height over the hypotenuse, which is 412. So if I'm solving for the height, I just have to go 412 times the sine of 71 degrees. Now I just plug it into my formula and it works out really cool. So I get 1/2 my base, which is 386. My height is 412 times the sine of 71 degrees. And what do we get for our answer? If we plug that in, it should be very large. It should be 75,183.9 square feet. Now, wouldn't it be nicer if we just had a formula so we didn't have to actually do all those calculations? Well, we do. And it's really kind of a cool thing. And this works any time that you have side, angle, side. This is, by the way, really SAS, side, angle, side. So we have to have 2 sides and the included angle in order for this to work. And really, we just substitute in a couple letters. We let the bottom one be B, we let the other side be C, and then A represents the angle. So the formula to find area is the following. Area equals 1/2 BC times the sine of A. And now this one you're going to want to memorize. Now what are B, C again? B and C are the two values that surround the angle, and A is the angle. And this will work every single time for area. We're going to apply it to the 4 triangles on the other side.